Hey everyone, this is Richard Bowen. I am representing our group in our final presentation about moving toward a sustainable campus fleet. So, our project had to do with modifying the transportation system here at IU so that it might become more sustainable and have a lower carbon footprint. Much like other places that use transportation systems, Indiana University is no exception in that it uses diesel-fueled buses to move people from place to place. However, these buses aren't very fuel efficient. They run on average about 3.5 miles per gallon, and diesel, as you well know, contributes to climate change and other environmental harms, as it's a fossil fuel. The conventional alternatives of fossil fuel transportation aren't very affordable or available here in Bloomington, and some of them don't really work for IU's needs. For example, the maintenance crews need heavy-duty hauling vehicles that are incompatible with electric vehicle technology, so we needed a different approach. What we wanted to do was convert diesel-powered buses instead to run on waste vegetable oil. We wanted to target buses specifically because of because they move people around so frequently and are active so often. Some of the benefits and advantages of this approach is it's making use of a resource that would otherwise be waste. Restaurants often pay to dispose of waste vegetable oil. We could take the waste vegetable oil off restaurants' hands and put it into buses. That would save the restaurants money and it would save the bus system fuel costs. Waste vegetable oil is also a carbon neutral fuel source. Some of the carbon is reabsorbed by the cultivation of vegetables for future vegetable oil. Also, the carbon intensity of combusted waste vegetable oil is about 78% lower than that of diesel. Also, this is a cheaper option than other alternatives. This is less disruption to the existing transportation system. It's cheaper to retrofit to use waste vegetable oils than to buy new electric vehicles, and you can use the same technology you already have. Again, as I said before, we wanted to focus on the bus system just because of how frequently it was used and because of the inefficiency associated with it. As you might remember from previous discussions about fuel consumption, it matters a great deal with respect to technologies that consume a lot of fuel, the intensity of the fuel being consumed. To do this, we contacted Brian Nugent, the director of the campus bus service here at IU, and we secured enough waste vegetable oil from local restaurants to run a small experiment. To gain Mr. Nugent's support, we used the influence strategies of liking and priming. We wanted to induce positive feelings about this transition in Mr. Nugent to make him more receptive to the idea. And in terms of priming, we initially asked if we could convert the whole fleet. This actually was a big ask, and that made it easier for us to get a smaller ask, which is just to try a single vehicle or a small group of vehicles instead. We ran into a few issues at the outset. Mr. Nugent told us that if we modified vehicles to run on waste vegetable oil, that would void the warranty. Also, any buses purchased after 2009 had higher emission standards and particulate matter burning systems, which were incompatible with waste vegetable oil. However, he did offer us the use of a bus from 1999 that was scheduled to be retired, available for modification after we got approval from IU's legal and research departments. We intended to use this bus to run an experiment and provide a proof of concept that our idea works. To do this, we wanted to run the bus along the same 20-mile route, once with diesel and once with waste vegetable oil. We would measure the fuel before and after each route, and we'd estimate the emissions based on how much fuel was consumed. This was necessary to compare the two different types of fuel and to determine the expected emissions reduction between the two. So before we began, we calculated that diesel emits about 22.38 pounds of carbon dioxide per gallon. Waste vegetable oil emits 78% less, so that's about 4.928 pounds per gallon of waste vegetable oil consumed. Again, as we mentioned before, the average expected fuel economy of our buses is 3.5 miles per gallon. We estimated that if the buses ran for 8 hours a day, 5 days a week, that would be 2,080 hours annually, and that they would be running about 12 miles per hour on average. Our sources also suggest diesel and waste vegetable oil are roughly equivalent in terms of fuel efficiency, so we expect that we would consume roughly the same amount of fuel for both trips, for both routes. Unfortunately, we did not receive permission from legal and research in time to actually receive the bus and conduct the experiment, so we don't actually have any data to confirm whether or not our project was successful. Our calculations are instead estimates, unfortunately, instead of actual results. So based on our estimates, at 3.5 miles per gallon, we estimate that 128 pounds of carbon dioxide would have been emitted over the 20-mile diesel run, and at a 78% reduction in carbon intensity from waste vegetable oil, it would be about 28 pounds instead of carbon dioxide for the vegetable oil run. So that means that there's about 5 pounds of carbon dioxide abated per mile by using waste vegetable oil instead of diesel. If we project this over a year, then that would be about 124,800 pounds of carbon dioxide we could expect to abate every year. And as the buses have a lifespan estimated from anywhere between 12 to 20 years, for each bus over its lifetime, that could be anywhere from nearly 1.5 million pounds to nearly 2.5 million pounds of carbon dioxide abated per bus per lifetime. This is potentially, if we've done our estimations properly, a huge potential for carbon abatement. From this project, some of the lessons we learned is that we should try and identify and reach out to our stakeholders as soon as possible so we don't run into the same issue where we don't have enough time to actually get the bus and run the experiment. If we find who's important to talk to and we get in touch with them as soon as possible, we could get an expedited approval process, get some more information sooner. And as we had to do in this project, talking to people sooner would help us identify alternative approaches if necessary and do it quicker. The gatekeepers in this project were the major obstacle in this case from legal and research departments. So another lesson we took away was to identify who these gatekeepers are and try and prepare some arguments and supplementary materials to address their concerns as soon as possible to get that approval as soon as we can. Also, finally, as a final time-saving measure, we could try and run multiple phases of our project simultaneously where that was possible. Lastly, were we able to run this experiment again, instead of just estimating emissions, we'd like to be able to actually calculate what the emissions would be based on some kind of emissions measurement system. So for future work, because we didn't actually get to run the experiment, we want to actually try and run it. Again, as we mentioned before, we would like to get some technology to have some precise measurements of fuel consumption and carbon emissions. And if our experiment is successful and our estimates are verified, we'd like to use this successful run as a proof of concept to create organically growing movement toward a diesel to waste vegetable oil transition. Thank you very much for taking the time to listen to our presentation.